Let's investigate another scenario where related rates can occur. Suppose two boats leave a port at the same time. One traveling east at 30 miles per hour and another is traveling southeast at 20 miles per hour. At what rate is the distance between the two boats is changing? 30 minutes after they leave the port. I'm going to go ahead and draw two pictures here. One of them is indicating a port that is on the far left. And I'm going to indicate that port with just a dot, with a simple dot. Now the faster boat is traveling east. So I'm going to draw a distance that shows a greater distance than the boat traveling southeast. So even though I'm not fully to scale, I still need to make sure I draw the faster boat with a greater distance. I'm going to go ahead and call this a distance of A. I'm going to call this a distance of B. And the two boats are at the end there. This will create a distance, which I will call lowercase c. Now my moment picture is very similar. It's just that it's going to look bigger, because when we take a picture later on, the boats are now farther apart. How much farther apart? We don't know. But we're trying to figure out how this distance is changing as the boats get further and further apart. And there is an angle here. We do know this angle. There's an angle that is fixed. Traveling southeast will yield a 45-degree angle. Now, 45-degree angle is actually pi over 4. Pi over 4 radians. So that angle is fixed. What's a relationship with an included angle, two sides, and the opposite side of that included angle? That relationship is called the law of cosines. Law of cosines is the extended version of a Pythagorean theorem. And we know that capital C here is pi over 4 radians. That simplifies our relationship to be this. And that's because cosine of pi over 4 is in fact equal to root 2 over 2. We could go ahead and implicit differentiate this. Remember, everything here is a function of time. So C is a function of time, B is a function of time, and A here is a function of time. So we have three functions of time. So when we implicit differentiate, we got to remember we are differentiating with respect to time. That means there will be chain rules taking place. And over here, there's a product of two functions, namely A times B, and we're going to need the product rule here. As long as c is not 0, we could simplify and solve this relationship for derivative c with respect to t. Now, do we know all these values at that moment or at that instance that we're trying to take a look at? So at the very moment here, do we know what A, B, and C are? If so, we're in good shape. So why don't we draw a separate picture for the moment? So we know that after 30 minutes, the faster boat has traveled 15 miles an hour. Or I should say 15 miles. The slower boat has traveled 10 miles. Could we get C? And the answer is yes. We definitely can get C because we know this right here, the included angle between A and B, is actually pi over 4 radians. Let's go ahead and solve for C using the law of cosines. C is either going to be positive or negative. A squared plus B squared minus 2 times A times B cosine of pi over 4 radians. Now simplifying this, we know C has to be positive. Most of this is simply algebra. Just be very precise with it. Be very confident with it. And you'll be good shape. And we already know what dAdt is. dAdt is actually 20 miles per hour. We also know what dB/dt is. That is actually 30 miles per hour. And we can go ahead and plug in all these values to find derivative C with respect to t. Simplifying this, we get this expression in the numerator. We can certainly reduce this by 5, and we get 130 minus 60 over this denominator. You might realize there's a pattern going on. And that simplifies as well. That's a very nice pattern to see. We actually know that the derivative of c with respect to t is simply going to be this expression here. You do have to indicate the units. So what is c measured in? C is measured in miles. The horizontal bar means per, and the time is actually measured in hours, or hour. So, at the moment, 30 minutes after leaving the port, the boat, or I should say the distance between the boats is increasing. At about 21 and 248 thousandths miles per hour. Notice you do need an exact answer. And that exact answer is indicated right here. More importantly, you should be able to interpret and write a brief summary of what you found.